problems 7 through 12, you're going to first find the inverse informally and then verify that f of f inverse of x gives you x and f inverse of f of x gives you x. For 7, f of x is 6x. So I'm going to find a function that undoes that. So I'm going to write a table with f and f of x, and I'm just going to pick some sample numbers. And f of x is minus 6, 0, 6, 12, 18. So to go from f of x to from x to f of x, I'm multiplying by 6. And to go back from f of x to x, I'm dividing by 6. So I'm going to say my f of x, my f inverse is 1 over 6x. And to verify that, I'm going to write f of x, f of f inverse of x, replace f inverse, rewrite f in box notation, and what goes in the box? And to verify the f inverse of f of x, I'm going to replace f of x I'm going to rewrite f inverse in box notation. And that's how you do that group of problems. For 13 through 16, verify f and g are inverses. For 13, f of x is minus 7 over 2x minus 3, and g of x is minus 2x plus 6 over 7. So to verify this, I have to show that f of g of x equals x and g of f of x equals x. First step is replace g of x. I'm going to write f in box notation. Fill in the box. And simplify. First of all, my minus signs can cancel. My 7s can cancel. So I'm going to rewrite. I have a factor of 2 in the numerator that I can take out. 2 times what is 6? 2 times 3 is 6. Now these factors cancel. I'm going to rewrite here. And x plus 3 minus 3 gives me x. G of f of x. I'm going to replace the f of x. Rewrite g in box notation. Fill in the box. and start simplifying. I think first I'm going to distribute my 2. Two over 2 cancels. 2 times 3 is 6. I'm being very careful to maintain my minus signs here. All I have left is terms that add and subtract, so I can drop those parentheses. Plus 6 minus 6 cancels. And the 7s cancel, leaving me with negative x. Those minus signs cancel, leaving me x. For 17 through 20, you're going to use the graph of the function to sketch the inverse function. So here's the original graph for number 20. So I'm just going to very carefully draw the graph of the inverse reflected over the dotted line, which is y equals x. So it looks like this. For 21 through 24, I'm going to verify that f and g are inverses. For this set, I'm going to choose to do it algebraically. For 21, f of x is 2x, and g of x is x over 2. So I'm going to verify that f of g of x equals x, and g of f of x equals x. I insert g, rewrite f in box notation, put x over 2 in the box, that equals x. For g of f of x, rewrite f, rewrite g in box notation, plug in 2x, and both of those are valid. For 25 through 28, I have to verify graphically because I chose algebraically for the first set. I'm going to demo doing that on Desmos. To label my graph, I'm going to add a note, and I'm going to say, my name is Mr. Shadle. Don't put my name as your teacher, put your name as the student. This is section 2.7, number 25. F of x equals x cubed. And g of x, if you don't know how to write cube root, write what goes inside the sign and put it in parentheses and raise it to the 1/3 power. Or I could look for my function, click on the functions button, scroll down to nth root, and that's a 1/3 root, and that's 8x under the root sign. That's the same line. And now to verify, I just need to look at y equals x, and I'll make that a dotted line. That's my verification, and this is what I would screenshot and turn in for the problem.